I'm the linker. I put .o files together like a puzzle. This gives modularity, meaning you can work on separate pieces for me to put together and not have to work with one giant mass of code. You can also reuse various pieces in other projects. I'm also great for efficiency, since you don't have to recompile every puzzle piece when you've only changed one and want to run it again. Therefore, I'm very important for larger programs. I take relocatable object files, .o files, and then I put them together into an executable project file, a.out files, which is the program's final form. Don't worry about needing to understand .o files though. We want at least 1 or 2 people to pass the class. However, it is good to know a bit about how I work in order to avoid compatibility errors between various files and libraries. Most of the work has already been done by the time you get to me. I only have to do 2 things. I do symbol resolution and then relocation. Relocation is where I'm putting the .o files together. These are the type of symbols I resolve. All functions are global in C. Local variables that are not static do not matter to me because they only act within a single file. I don't know anything about them. In fact, I don't even know what I'm talking about right now. Some symbols are strong and others are weak. If there are multiple symbols with the same name, I favor the strong ones. I go by 3 rules. Rule 1. There cannot be multiple strong symbols. I will get upset. Rule 2. If there's strong symbols and 1 or more weak symbols, I will choose a strong one. And Rule 3. With multiple weak symbols, I will choose arbitrarily.
When a computer runs, some of the different parts must agree on things such as word size, Indian, whether or not to use ELF, and the address of the first instruction. Different agreements are relevant depending on which parts you are talking about. The linker cares if the .o files are compatible. Linker errors are the most common in large projects because they contain more pieces. Shared object files, .so, are a specific type of relocatable object file. All object files are by a specific object file format. These formats can vary from one device to another, but the concepts are still similar. We talk about the executable and linkable format, or ELF. There is also the loader. Don't look into his eyes. He finishes the linking at compile time, at load time, or at run time. He takes in an ELF file and sets up the stack and data. He also resolves references to dynamically linked library functions. This is the format of an ELF, relocatable object file. It's an executable and linkable format. The ELF header is a 16-byte sequence dictating the size and ordering of the file. You can view this data using object dump. ELF header says how big each of the segments are, so it doesn't get lost and confused. .text is the code of the program. The .rodata, .data, and .bss hold variables. The difference being .rodata is not being something you can change and .data being initialized and .bss being not initialized or initialized to .o. Some systems use common for uninitialized global variables. .symtab is an array of structs called the symbol table. Each struct includes name, size, and location. .reltext and .reldata have location information. The .text and .data reference what we discussed higher up. .debug unfortunately does not make all your code have no bugs. This holds the original C program in a debugging symbol table. You can use a -G with your GCC to put the information about the source code into the .debug.